When you talk about parallel lines, we know that parallel lines have the exact same slope. So if I have two parallel lines, they're never going to intersect each other, so they have the exact same slope. When we talk about perpendicular lines, it says two different non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. And I'm actually going to change that a little bit. I don't want to say negative reciprocals of each other. I'm going to say opposite reciprocals of each other. It has the same meaning, but we have a tendency when we hear the word negative to want to make everything negative. And as you'll see, that's not true. Okay? So perpendicular lines have a slope that are opposite reciprocals. Parallel lines, exact same slope. Perpendicular lines, opposite reciprocals. Now if you look at this picture, we have a square here, and it says that show that FG and GH are perpendicular sides of the figure EFGH. To show they are perpendicular, we need to show that their slopes are opposite reciprocals. So let's start with FG. FG is represented by this segment right here. We have 2 points, F and G. Remember, when we have 2 points, we can use our slope formula to find the slope. So for FG, let's find the slope of FG. I'll call this x1, y1, x2, y2. Okay, sorry, that's a little hard to see. But our y2 here I said was 0, minus our y1, which is 3, over x2, which is 3, minus our x1, which is 2. 0 minus 3 is a negative 3. 3 minus 2 is 1. So the slope of FG ends up being negative 3. Now let's find the slope of GH. Oops. Okay, so slope of GH. I did name these x2, y2, so I'll name this x1, y1. y2 is 0 minus y1, which is a negative 1, over x2, which is 3, minus x1, which is 0. Now if you look here, keep, change, change. 0 plus 1 is 1. 3 minus 0 is 3. So let's compare these two slopes. We have 1/3 and negative 3. Are they opposite reciprocals? Well, they're opposites of each other, right? This is negative, this is positive. Are they reciprocals? Yes, they are. If you took 3 over 1 and you flipped it over, you get 1 over 3. So, show that they're perpendicular. This is how you show they're perpendicular. Okay? They are perpendicular because their slopes are opposite reciprocals. We'll be able to use that information then to write equations. So if we wanted to write an equation for this line here, okay, I need my slope. So if I'm talking about FG, I need 2 things. I need my slope and I need my y-intercept. Anytime to write an equation, we need slope and y-intercept. Well, we know our slope of FG is negative 3. But I don't know where it hits the y-axis. It's okay because I can take one of these points and it really doesn't matter which one you take. And I can plug it into slope-intercept form to write an equation. Okay, just like we've been doing. This is your x value, this is your y value, so I can say 3 equals my slope, which is negative 3 times 2 plus b, solving for b now. Add 6 to each side. We get 9 equals b. Okay, so an equation for FG, y equals my slope, which is -3, x plus my y-intercept, which is 9. Now we can do the same thing here for line segment GH. Our slope for GH, which we've already figured out, is 1/3. Our slope, again, is 1/3. And we don't know, well, we do actually know the y-intercept, don't we? If we look here as our y-axis, we can see it hits the y-axis at -1. Remember, if we can tell that information from the graph, we don't need to figure it out. You could plug in 0 for x. Watch what happens real quick. Okay, if I plug in 0 for x and my slope of 1/3, and y plug in -1, oh look, these cancel out and we get b equals -1. Okay, so keep in mind that that b, remember, stands for your slope-intercept. So you don't need to plug it in if you can see that it's hitting here on the -1 on the y-axis. So an equation for GH is y equals your slope of 1/3 times x plus your y-intercept of a -1. Or again, like we've talked about in the past, 1/3 x minus 1. The important thing to remember from this section is that perpendicular lines are, the slopes of perpendicular lines are opposite reciprocals of each other. Meaning if one's positive, the other one's negative, or vice versa. And then they're also reciprocals.